Welcome to this video. Today we're going to look at creating 3D models using data from the Digimap service, and today we're going to look at how to do this using ArcGIS Pro, which is software from Esri. So there's a number of different data sets we're going to look at today. We'll talk about these in a little bit more detail as we go through the practical exercise. These are all downloaded from the different collections of Digimap as shown in this slide. Now, as I said at the start, the software we're going to use is ArcGIS Pro. It's available from the esri.com website, and the current version is 3.4.0. That's what we'll be using today. So without further ado, we will jump into software and we will start building up a project. So here's the ArcGIS Pro start window. I'm just going to start a new map, a new window without a template, and then I'll just add a map to this. So we've got our sort of basic map environment set up here. Now there's a number of different data sets that we're going to use today. So the first thing I'm going to do is create a folder connection using the catalog pane on the right hand side here. I'm going to add a new folder collection to my working folder. So I've got a folder with all my data in. I'm just going to connect to this folder so that we can then access this easily. So I'll add that in, and we've got a number of data sets that I've downloaded from Digimap. So the first data set that I'm going to add in is the aerial imagery. I've downloaded a couple of aerial image tiles. Before I add these to the project though, I'm going to set the coordinate reference system, because at the moment the data, whilst it's provided in British National Grid, the data set itself doesn't have a projection, any projection information with it. So I'm going to right click on each of these two images, bring up the properties window, scroll down to the spatial reference, click on this button here, and I'm just going to set this. So I've got British National Grid set as a favorite. I'm just going to set this to British National Grid, and then I'll repeat that process for the second image. So go in here, set this to British National Grid. Okay, and now having done that, I'm going to add both of these images to our current map window. And the map is zoomed in. If we just zoom out a little bit, you'll see we're in the centre of Edinburgh here. So this is Edinburgh Castle right in the centre. And you'll see if I turn these images off, they align perfectly with the street map data that's showed underneath the base map data there. Now the second data set I'm going to add to this this scene here, this map, is the geology data downloaded from Geology Digimap. So the geology data that I downloaded was the 1 to 50,000 scale geology data, and I'm going to add in the bedrock data. You'll see in the catalog pane on the right here, two items are shown. We've got the actual shape file, which is the raw data, and we've got a .lyr file, which is an Esri style file. So it's a layer file effectively, but this is provided by the British Geological Survey for the data, and it just means when you add this to your map, the data will be styled using the standard color scheme that BGS use for the data. So there we go, there's the nice colorful geological data. And if we zoom in a bit, we can see this is the area around Edinburgh Castle. So here's Edinburgh Castle. And if we put the geology data on top, we can see that there's a particular colored feature here. Now, here's our sort of simple map. What we're going to do is turn this into a 3D map. So I'm going to turn off the geology data and just zoom in a little bit on the castle. And if we go over to the view menu, there's this convert option on the left hand side here, and we're going to convert this to a local scene. It's a local scene because it's a small area. If you were dealing with global data or much larger area, you would change this to convert this to a global scene. Now I'm just going to convert this to a local scene, so the map's going to render. We'll just wait for this to display. Here we go. So here we've got Edinburgh Castle, and it looks just the same as our 2D map as before, but if we click and hold the mouse wheel down and drag it up, we can see that we've now got a nice 3D visualization of this area. So there's Edinburgh Castle and the surrounding parkland around the other side there. So this is quite nice. So all we've added to our project at this point are two aerial images and a bedrock layer downloaded from Digimap. We haven't actually added any terrain data. This is one of the good things about the Esri platform and ArcGIS, is that they already have, as you can see in our contents pane here, they have world elevation. So there is elevation data available, freely available to use in the system for the whole world. So whilst we haven't had to load it in, we can actually see all our data in 3D using their world elevation data that's provided for us. Now, because it's a world data set and it's created from lots of different sources, you can see here that it's not very detailed in this particular area. The road underneath the castle here appears to slope at 45 degrees, which would be obviously is not the real world case in this situation. It's actually a flat road. It'd be very difficult to drive on that. So what we can do is we can improve the terrain data. And so instead of using this free world elevation data, we can use some terrain 5 data, which has been downloaded from the Ordnance Survey collection of Digimap. Now in here you'll see we've got two .asc files. These are ASCII files which contain the terrain data, it's terrain 5 data. So terrain 5 is 5-meter grid cell size, so it's fairly detailed. You'll see it's dropped them in a 2D layers section in my project here, but these are actually terrain surfaces. So what we can do is click and drag these down and drop them into this elevation surfaces section here. And then what the system will do is it will use those as the basis to create the 3D model. Okay, now that's finished displaying, we can see that if we zoom around and have a look at the road now, we've actually got a much more detailed terrain surface here. The road is being displayed horizontally, and this is now using the OS Terrain 5 data that's been downloaded from Digimap. So we can turn off this world elevation layer here, and it'll just speed up processing so that you'll see the terrain in the distance disappears. It's no longer rendered. Okay, so now to go back to our 3D scene, and we'll turn back on the geology data that was added to the map before. If we turn this on now, this will be draped over the 3D surface, and it'll come in and it'll use the colours used by the British Geological Survey. And you can see very nicely now that this particular area, so where the castle is, Castle Rock, is made of very different material from the surrounding area. And if we click on one of these features, we can see that the Castle Rock is actually a microgabbro igneous plug. So this is an igneous rock is a volcanic rock, so it's quite a hard rock. If we click on the green area surrounding this, the pale green area, you can see we've got a sedimentary sandstone. So sandstone is a lot softer, and that explains why the castle is positioned on this rock, because this is a much firmer rock and the surrounding terrain has been eroded. Okay, so that's our first part of sort of 3D visualization. The next thing we're going to do is we'll go back to our 2D map, and we're going to look at 3D buildings. So there are a couple of different 3D datasets, buildings datasets available from Digimap. The first one we're going to add is the one called Building Height Attribute, or BHA, which has been downloaded from the Ordnance Survey collection. Now I'll just add these to our current map. Again, these have been downloaded as two separate tiles of data, so I just need to add these to our current map. In GDB is file geodatabase format, and you'll see we've got two tiles, two square tiles of data that overlap our area of interest. Now, building height attribute data from Ordnance Survey is provided with a number of different attributes. So here's a little drawing that shows the information that's provided. So Ordnance Survey have surveyed the whole country and provided this information, and for each building you get a minimum absolute height, a maximum absolute height, and an H2, a height 2. So the maximum height is the apex of the roof or the chimney pot or the spire in the case of a church. The absolute height 2 is effectively the height of the building, so sort of to the eaves of the roof, or in this case, the eaves of the roof here. And the minimum is the minimum point on the ground, so this area on this schematic. From these three absolute values, they derive two relative values. So rel h max is the maximum relative height, and then rel h2 is the relative height to the sort of base of the roof structure. So all this information is provided from Ordnance Survey in the building height attribute dataset, and that's what we've loaded on here. So each one of these features, if I click on one of these, you'll see we've got our absolute height minimum, absolute height 2, absolute height max, and then we've got rel max and rel h2. So these are the different values. Now, the first thing we're going to do to process this data is we've actually got quite a lot more buildings than we need for our 3D visualization, and just to make sure that it runs smoothly and isn't too slow, we're just going to chop out the buildings that we're interested in that overlap with our map. So if I go back to the map tab here, and I'm going to select just the buildings just roughly that overlap with our imagery area, because these are the only ones we're interested in, and I'm going to merge these into a new data set. So going to the geoprocessing panel, I'm going to find the tool called Merge, and we'll open this tool. And we're going to choose our two input data sets. So these are our two building data sets. And the output data set, sorry, I should say here, yes, so by default it will just use the selected records from the two data sets, which is perfect, that's all we need. The output data set, it'll drop this in a default database that it'll create for the project in a temporary directory. That's fine for this particular purpose, so I'll just run this. And you'll see now, if I zoom out a little bit, turn off the original two data sets, we've now got a data set which is just the merged buildings that in the area of interest. So I will remove the original two data sets that we downloaded from Digimap because we no longer need those, and we're just going to use this smaller version. So this has been dropped into the default database, and there it is. There's the data. So if we go back to our 3D scene now, and what we're going to do is we're going to add this building data set in so we can see it. So we'll add this to our 3D scene. By default, it'll drop the data into the 2D layers section, so it'll just appear draped over the terrain surface. So each one of these buildings is there, the footprint's there, and you'll see it lines up nicely with the aerial imagery. But they're just 2D flat features at the moment. To make these 3D, we need to move these into the 3D layers section here. So we click and drag, drop it into the 3D layers section. You see the map will redraw. Again, they'll still be flat. We need to now tell the system how to make these appear. So we go onto this feature layer section, and in this extrusion area here, we choose the drop down, and we're going to extrude these based on the maximum height of the ground surface. So if we choose the max feature there, the field we're going to use in this is the rel h2 field. So that's the relative height from the ground up to the eaves. And it is in meters, so that's fine. The data is provided in meters, so we don't need to change the units. So the map's going to re-render, and if we just zoom in a little bit, you'll see we've now got 3D buildings that have been extruded to the height of that rel h2 attribute provided with the data. So this is quite a nice, it's very quick, simple 3D representation. You can see it's very detailed. The building outlines included in building height attribute from Ordnance Survey use the same outlines that you find in OS MasterMap, which is the most detailed data you can get from Ordnance Survey for Great Britain. So it's quite a nice, simple visualization, and all the information is still there, so you can click on these features and see that information, see the attribute information provided. Okay, so that's building height attribute. Now I mentioned that there are a number of other building data sets that we could use. The next one we're going to look at is one that's been downloaded from the Verisk collection, and it's called UK Buildings. This is provided in GeoPackage format from Digimap, but we can add this directly into our 3D scene here. So we'll add the data to our 3D scene. And just like before with the building height attribute data, it gets dropped into the 2D layers section. To make it 3D, we'll drag it into the 3D layers section, but before we do that, we're going to color this. Now the various data, if we click on one of these features, you'll see it has an age attribute. You don't get this information with the building height attribute data from Digimap from the Ordnance Survey collection, but Verisk have run the data that they've got through some processes to try and determine the age of the buildings. So if we click on some different features, you'll see this one's classed as historic. Obviously the Edinburgh Castle features will all show in as historic. There'll be some modern buildings in various places. This one here, 60s, 70s. So this information is quite useful, and we can use this to style the data. So if we go to our symbology tab here, rather than showing it as a single symbol, we will choose unique values. And the field we're going to use is the age field. And we'll just use a color ramp because it just shows the age a bit nicer. If we show them all. And we're going to choose this one here, cold to hot. So what we'll get is we'll get older buildings displaying as blue and then newer buildings displaying as orange, and any unclassified ones will come in red. So now we can see if we just sort of go to a bird's eye view, we've got a whole range of ages of buildings. There's lots of blue, we're in the centre of Edinburgh here, there's lots of historic buildings. These sandy stone coloured ones here, these are modern features. And we've got 60s, 70s ones showing us this orangey colour. So that's quite nice, and now we can extrude these buildings and see this data in 3D by dragging it into the 3D layers section. Oops. So we'll drag this into here. And just like before, we need to then tell the system what to do, how to extrude this. So as we can see, each building has got a height attribute value. So we can extrude these features using this height attribute value. So just like before, on the feature layer panel, we choose the type drop down. We're going to add this to the maximum height. The field we're going to use is the one called height. And again, the data is provided in meters, so we can just leave the units set as they are. So there we go. So now we've got a 3D scene, and it shows the building footprints extruded up into 3D. We've got quite a nice visualization that shows the different heights, but also these are now colored by age. So we've got this 60s, 70s building here. We've got the historic buildings on top of Edinburgh Castle Rock. We've got some modern buildings around here. So there's a whole range of information provided here. Okay, so the final thing we're going to do to our 3D scene now is add in some trees to make it slightly more realistic. Now I'm just going to flip back to our 2D map, and we're going to add in some data downloaded from Digimap. It's from the Ordnance Survey collection, and the dataset is called the National Tree Map, so NTM for short. This dataset is provided by Digimap in GeoPackage format, and it consists of 3 separate feature classes or datasets underneath. Now I'll just add these to my project, and we'll just have a quick look and see what they all are. So if I zoom into this area around the back here, now each tree is being captured as a point and also as a canopy and a crown. So if we just look at the points first, all the features have the same attributes. So if we click on a feature, we get the height, the maximum height of the tree. We also get the mean height, the area that the canopy occupies, and the perimeter, so the outline of that canopy. There's also some other information there and dates, things like that. So for each of these trees, it's provided as a point. It's also provided as a canopy. So this is where they've sort of effectively digitized round from aerial photography, trying to capture the spread of the canopies of each of these trees. But they also provide it as stylized crowns. So these effectively show the extents of each tree, but as a stylized circle. So you see we've got a whole range of different sizes of trees in this area. And we're going to style this and try and create a 3D representation that includes trees. What we'll do in our 3D scene is we're just going to use the point data, but we're going to use some symbology provided by ArcGIS Pro to display these as trees. So if we go back to our 3D scene, and I will just add in the point data to my 3D scene. Now to see this in 3D, we need to drag these points out of the 2D section into the 3D section. Now before we stylize these as trees, I'm just going to change one of the properties. So I'll bring up the properties window for this feature, this data set. And on the display tab here, we'll set this as display in real world units, so we can use the height values in the data to display as actual heights and accurately using this. So we need to set that to display in real world units, not screen units. So having made that change, nothing will change in the map. It will redraw, but it will look just the same. But it just means we can access those height values, and we know that those height values are provided as meters, and we can use that to make sure that our tree features are the correct heights. Okay, so we're going to go to the Symbology tab now for our trees, and the symbol we're going to use, if we just search for tree in this gallery, you'll see there's lots of tree symbols. So there's 3D ones. If we scroll down, those 2D trees, there's a whole range of different tree symbols in here. I'm going to style all these as oak trees because it's quite a nice symbol. The data doesn't, in the National Tree Map, doesn't have any information on species. If you had information on species, I just click on one of these trees, you'll see there's nothing that tells me what species this tree is. If you had information on species, you could effectively use the attribute information of species to derive the symbology. So if you knew it was an oak tree, you could style it as an oak tree. If you knew it was an ash tree, you could style it as an ash tree. But for simplicity in this demonstration, I'm just going to symbolize all my trees using this realistic 3D vegetation white oak symbol. And you'll see when I choose that, we now get a whole bunch of trees displaying, and they all appear exactly the same. So we've kind of got a sort of forest in this area, which isn't the case because they're not that densely packed. It's just that they're all displaying the same height, same size. But because we know that these tree features have got different heights and sizes, because it's all stored in this attribute information, we can use that to style these trees and size them more appropriately. So if we go back to the Symbology tab, having chosen the tree to use, on this section here that says Vary Symbology by Attribute, we can change the size of our features based on their attribute values. So because trees are they don't scale proportionally, we don't want to maintain the aspect ratio. We want to be able to scale the height and width differently. So the height of the tree, we're just going to set to that maximum height value. There we go. So now our trees will be displaying at their true heights, but they're all showing the same width at the moment. So the width field, we don't have a width field in the data, but what we do have is a perimeter. And using a bit of maths, we can actually say, right, if we divide the perimeter by 3.14, which is an approximation of pi, that'll give us the diameter of the tree canopy. And you'll see now our features look a lot more realistic. So we've got trees of many different sizes now. We've got tall, thin ones, we've got tall, wide ones, we've got small, shrubby type ones. And this is looking a lot more accurate as to how the actual data is. And you can even see the shadows in the underlying aerial imagery there. So this is looking very nice now. Our 3D scene is looking pretty realistic. We've got buildings coloured by age, but we've also got trees showing in their correct locations and sizes. Now, the final part of this that I wanted to show you was to maybe see how you could export this data. And one of the nice things you can do with ArcGIS Pro is you can create animations, 3D animations. So if we go up to the View menu and we go to the Animation section here, press this Add button, we can create a very simple animation that takes you through some of the data, through some of the scenes. So we'll create our first frame at this point, and then we'll zoom in on this building. And we'll add another frame at this point. Then if we zoom around to the other side of the castle, and we'll pan around a little bit so we can see Edinburgh Castle. And we'll add a frame here. And now you can play this animation using the play button. And you'll see it zoom in, goes around the building to the other side of the castle and zooms out. So that's very nice, and if you're happy with that, you can obviously edit this, you can change things, you can change the order, you can do various things with this. When you're happy, you can export this as an image file. So using the export option here, there's a load of presets for different output formats, and you can also change the settings. So it'll tell you the format it's going to do, how many frames per second, and in this section you get the option to change the quality. When you're happy with the settings, it tells you where it's going to put it. You can press the export button and it'll go through and generate that file. Now, it does take a few minutes to generate a file, but it's quite nice once it's done. Here's one that I created previously, which zooms through. You'll see the quality of the rendering is really good. It's very detailed, and it's quite smooth, and it goes around the frames that I created. So there we go. There's a quick demonstration, a quick run through of how to create 3D scenes using ArcGIS Pro and data from Digimap. So we've done some very simple display of data. We've used data from a variety of different collections in Digimap, and we've created our final 3D scene that shows the buildings coloured by age from the Veris collection and the national tree map data to show the trees. Thanks very much for watching. I hope that was useful, and look forward to seeing you on another video soon.